Alright, so in the last video we have done the breakout for the controller and the crystal circuitry as well as the reset. So let's just go ahead and complete the schematic. So as we had discussed in the introduction video, we also need a facility to program the controller from the in-circuit programmer or ICSP. And as we had discussed in the introduction video, so these were the pin connections. So this is master in, slave out, this is serial clock, reset, VCC, master out, slave in, and ground. So let's just make this connection with a 6-pin connector. Again, to place a component, hit A on the keyboard to bring up the dialog box, and then type in CONN. So in this case we require a 3x2 connector, so we'll pick that, and we could place the labels or we could draw the wires. Since it's part of the same section, or it is adjacent to the microcontroller, so we'll just go ahead and place the required wires. So the pin number 1 is goes to master in, slave out of the controller. So this is master in, slave out, so draw a wire from here. And pin number 2 is serial clock, so the serial clock is again over here. Alright, so pin number 5 is reset. So if you remember, we have placed a label for reset. We can copy the same label by keeping the mouse cursor on the label, and if you press C, it would copy the label, and we could place it on this particular pin. Now the next is the ground, pin number 6, or we could go to pin number 2, which is VCC, and again we could use the standard symbol for the VCC. And the next is master out, slave in, which should also be over here. And pin number 6 is the ground for the ICSP connector. Now you could also change the name of the connector. Alright, so the only remaining sections are the power supply and the USB to serial converter. So let's just go ahead and place those components. We'll do the USB to serial converter first. So again, select by browser, go to the Explore Labs directory and place the component. So we require the CP2102 USB to serial converter. So let me just place it here. Alright, you could move it little downwards. Alright, so as you could see again here, we have arranged the pins according to the functionality of the IC. So on the left hand side we have the pins for the USB connection, and on the right hand side we have pins for the output. So it gives the serial output on the right hand side. So, and all these pins are not connected or will not be using them. So let's just also place the USB to serial converter, so I'm sorry, the USB connector. So this is the USB connector that is required. Alright, so here again we can go ahead and interchange the parts here to match D minus or D plus, or we could go ahead and simply draw the wires as it is. So D plus of this goes to D plus of the connector, and same with the D minus, and the ground is common. And also remember to place the logical symbol for ground so that all grounds are common. Alright, so and also you would require a couple of capacitors with these ICs, a tantalum and a ceramic is the usual practice in series, so let's just put those as well. So one is the normal ceramic and another is with polarity, so it's CP, and we could both tie them to the VCC and ground, so this would be about 0.1 microfarads. So this is the value, and this could be about 10 microfarads. And also remember to place these capacitors near the IC when we draw the layout, and one of the terminals should go to VCC and the other to the ground. Alright, so again we would require a 3.3 volts output from the IC, and this pin would give us the 3.3 volts output. So let's just put a label for that. And also we had discussed in the beginning that the DTR works as soft reset for the controller, so you could place the same label for the reset so that the soft reset goes to the reset pin of the controller. Alright, now the remaining two important connections. So RxD of the converter should go to TXD of the controller, so let's just place label for that. Okay, so let's place a label from the perspective of controllers, so I'll name it as TXD and place it on the RxD pin, and I'll copy the same label and put it on the TXD pin of the microcontroller. Same with the TXD pin, I'll put a label as RxD. And one important thing to note here is it is recommended to copy the label and then place it to wherever the connection is required, because if we make a typo or typing error, it could damage the connection, or the connection would not be proper. So let's just make that, and these were the very simple and basic connections with the USB to serial converter. Now we could leave these pins unconnected, but this would show up error when we do a error rule check saying that these pins are not connected. So let us put a no connect flag to all the remaining pins. Alright, so this seems perfect. Now the only section remaining is the power supply. So you could arrange these blocks in a proper fashion. To move an entire block, just select it and move it with the mouse. Okay, so this is the microcontroller and this is the USB to serial converter. Now if we make sections of schematics like this, if this is the USB to serial converter circuit and if this is the microcontroller circuit, we could as well copy the entire block and take it to a new schematic in case if it is needed. So if we make sections of schematic or blocks of schematic, they can be reused later in new designs. So and to copy a schematic from one section to another, you could select it and you could click on the option save block, so it would save, and if you open a new schematic from here and paste it, you would have this block coming over to the new schematic. And this we will explore in the next few tutorials with separate examples, even creating schematics on different pages and linking them together. Alright, so for now let us proceed and make the power supply. So if you look back to our reference circuit, so this is the power supply circuit. So it's just a barrel jack at the input and a protection diode, a couple of capacitors and a regulator to give a 5 volts output, and a jumper to select power supply from USB or from the external power supply, and also LED just to indicate the power status. So let's just go ahead and put this up. Again, to place the schematic symbols will take the same library. So you require a barrel jack or a power jack and a regulator. Right now KiCAD supports placing just one component at a time, so this could as well be a forum question or discussion wherein we would like to have multiple parts placed at once. Alright, so we also require a 7805. Diode, and a couple of capacitors. So both the other pins are the common ground pins. Also, we'll go ahead and place the ground symbol. So this label will just name it as 5 volts. So this is 5 volts from the power supply. Okay, and yes, so we just require another couple of capacitors to be placed near the IC and LED indicator. Now let's just put the jumper wherein we could switch the power supply. So it's a 3-pin connector, so CONN, and it's 3, so let's place this. Yes, so if it is between 1 and 2, the power should be from the external power supply. So this is VCC. This VCC is taken in all our schematic. So this is the basic VCC and then entire schematic, and this pin should be the power supply 5 volts. Okay, now the USB 5 volts, we would take it from here, so we will not put a label to that pin, so let's just put a label. And I'll copy the same label to the other pin. So if the jumper is between 1 and 2, the VCC or the power will come from the power supply, and if it is between 2 and 3, the power would come from the USB. Alright, so basically this is the schematic. Also we'll put a LED and a indication LED and a resistor, so let's just put LED, a resistor, and this would be VCC and ground. Alright, now apart from the headers here, the Arduino would also have a power header. So it takes out power pins from the power supply, as well as the 3.3 volts output from the USB to serial converter. So it is arranged in a particular way, so let's just look at it. So the power connector is over here, so it also takes out the reset pin to test, so we'll put it in the same fashion. So it's a 8-pin connector, so 8. Alright, so this is the 8-pin connector. So I arranged it in the same line just to make it more accurate. So this is the power breakout. Okay, so the pin number 1 is not connected, 2 is not connected, and 3 is reset. So let's just copy the label for reset. These 2 pins are not connected in the Arduino design, just to maintain the aesthetics. So when we'll be placing the components, we'll get to know as to why these additional 2 pins were kept intact. So pin number 4 is the 3.3 volts output, so that we get from the regulator in our case. So this is the 3.3 volts. So pin number 5 is 5 volts. In our case, the 5 volts comes from the VCC label, so it could be either from the USB or from the power supply, so we just put that label. So pin number 6 and 7 are ground. And pin number 8 is the input power. So this is the input power from the power supply. So in case you need 8 or 12 volts for your external power supplies, you could use this pin. So let me just keep the same label name. So this is the option to place the label. Okay, so let me place the label here, V in, is VN. Alright, so let's just review if we have and see if we have done in fact all the connections. So yes, so this is the USB to serial. This looks complete. It just gives out 3 pins which are connected with the microcontroller. Then the power supply, it simply provides a 5 volts regulated supply which is switched by the jumper, and we have an indication LED. So let's just put the value for that as well. Alright, so the design looks complete in all regards, and just to inform you, the schematic is in fact the most important part in doing the design, because if we miss something in the schematic, the same reflects in the layout. So just be careful to review the schematic once you have put it up. And before we proceed further to match the components or to draw the layout, it is necessary to do error rule check. This just shows if we have made any errors. So, and before we do error rule check, it is required to number the components to give them the reference numbers. So let's just annotate all the components so that we will have reference numbers for all the components on the schematic. And to do annotation, just click on this particular icon. Then it would ask you to sort the components by X position in this fashion or in the Y position. To leave it to default, and we'll annotate it. It will just give you an error, a warning in case if you have done the annotation and you are trying to change it. So since we are doing it for the first time, let's just proceed and close this. Now you would see that all the components would have their reference numbers. So this is D1, this is C1, this is C2, and all the other values or the reference numbers for the components. Alright, so the final step would be to make a error rule check, and so let's just do it. Now this would throw up some warning errors as well as some critical errors. So all these errors that you see, it says that pin is connected to some other pin, but there is no pin to drive it. So it basically says the power out of one component should go to power in, and likewise, but we have made sure that the connections are proper in our power supplies, so you need not worry about the warning errors. So you could delete the markers and proceed. So in case if we leave a connection or if we leave a pin unconnected, that also is shown by the ERC. Now let's just check that. So if you test it, it will show that a pin is not connected, and you should be careful with this thing. So it will point out exactly which pin was not connected. Alright, so this is about the schematic, and moving further, we'll create a netlist for the schematic, and in the next session we'll see how to physically match the footprints, how to match the physical footprints with all the logic symbols that we have used to make the schematic. Alright, so thank you for watching. See you soon.